Your grandfather could work 12 hours in a coal mine or on a farm, eat bread, potatoes, and meat, and have enough energy to walk home and chop firewood. You eat organic kale salads, take multivitamins, and still feel exhausted by 3 in the afternoon. This isn't about work ethic. This isn't about laziness. The food you're eating looks the same as the food he ate, but it's not. It's hollow. The plants are growing in dead soil, and dead soil produces ghost food. Food that fills your stomach but starves your cells. We are weaker than our grandparents because the earth itself has been drained. In 1940, before the industrialization of agriculture, soil was alive. It wasn't just dirt. It was a functioning ecosystem, a dense network of bacteria, fungi, earthworms, and microorganisms that worked together to break down organic matter and convert it into nutrients plants could absorb. A single teaspoon of healthy soil contained more living organisms than there are people on Earth. These organisms didn't just exist in the soil. They were the soil. They created it, maintained it, and regulated it. Plants don't just absorb nutrients passively. They trade for them. Through their roots, plants release sugars and carbohydrates, feeding the bacteria and fungi in the soil. In exchange, those microorganisms break down minerals from rock and organic matter, converting them into forms the plant can use. This is called the rhizosphere, the zone of cooperation between roots and microbes. It's a partnership that took millions of years to evolve. The plant feeds the soil, and the soil feeds the plant. That soil was rich in minerals, not just the big 3, nitrogen, phosphorus, and potassium, but trace minerals like magnesium, zinc, selenium, copper, manganese, and dozens of others. These minerals came from the slow weathering of rock, the decomposition of plants and animals, and the endless cycling of life and death. A carrot pulled from soil in 1940 contained significant amounts of iron, calcium, and vitamin A, because the soil had those elements and the microbial network could deliver them. The food was dense, it was nutrient-rich. A small amount went a long way. Then we broke the system. In the early 20th century, a German chemist named Fritz Haber invented a process to synthesize ammonia from nitrogen in the air. Another chemist, Carl Bosch, scaled the process for industrial production. The Haber-Bosch process allowed humanity to create nitrogen fertilizer from thin air. Before this, nitrogen came from animal manure, crop rotation, and legumes that pulled nitrogen from the atmosphere through symbiotic bacteria in their roots. It was slow. It was limited. The Haber-Bosch process made it unlimited. By the 1950s, synthetic fertilizers were everywhere. Farmers realized they could grow bigger crops faster by dumping nitrogen, phosphorus, and potassium, known as NPK, directly onto the soil. Plants responded. Yields exploded. A field that used to produce 20 bushels of corn per acre now produced 100. It looked like a miracle. The Green Revolution was born. Humanity could feed billions. Famine was defeated. But there was a hidden cost. NPK fertilizers feed the plant directly. They bypass the soil ecosystem entirely. The plant no longer needs to trade with bacteria and fungi for nutrients because the nutrients are already dissolved in the soil water, ready to absorb. This is efficient for growth, but it has a catastrophic side effect. The microbial network, no longer fed by the plant's root sugars, begins to die. The bacteria and fungi that once broke down organic matter and released trace minerals have no reason to exist. The soil stops functioning as a living system. It becomes a sterile growing medium, a substance that holds the plant upright while synthetic chemicals do all the work. At the same time, farmers stopped returning organic matter to the soil. In traditional agriculture, crop residues, manure and compost were ploughed back into the fields. This replenished the organic content and fed the microbes. Industrial agriculture removed everything. The crops were harvested, shipped away, and sold. Nothing returned. The soil was mined, not maintained. Every harvest extracted minerals, and nothing replaced them except NPK. 60 essential minerals were ignored. The soil became an empty husk. The result is the Great Dilution. Between 1950 and 2000, the nutrient density of fruits and vegetables collapsed. Studies comparing USDA food composition data across decades reveal the scale of the loss. An orange in 1950 contained nearly twice the vitamin A of an orange today. Broccoli has lost over 50% of its calcium. Potatoes have lost almost all of their vitamin A and significant amounts of iron. Tomatoes, spinach, and carrots show similar declines across the board. The plants look the same. They might even be bigger and more visually perfect. But inside, they are hollow. This isn't a theory. This is measured data. Researchers from the University of Texas analyzed 43 fruits and vegetables, comparing nutrient levels from 1950 to 1999. They found significant declines in protein, calcium, phosphorus, iron, riboflavin, and vitamin C. The cause wasn't genetic modification or pesticides, it was soil depletion. The plants were growing in dirt that no longer contained the minerals they needed, so they couldn't concentrate those minerals in their tissues. You can't give what you don't have. The dilution effect creates a strange paradox. We are eating more food than ever, but starving for nutrients. Your body doesn't count calories, it counts micronutrients. When you consume food that is deficient in zinc, magnesium, or selenium, your brain doesn't register satisfaction, it registers deficiency. You feel hungry even after eating because your cells are still waiting for the nutrients they need to function. This drives overeating, obesity, and metabolic dysfunction. You're not eating too much, you're eating empty food. A person in 1950 could eat a single apple and get a meaningful dose of vitamin C, potassium, and fiber. That same apple today requires you to eat 3 or 4 to get the same nutritional value. But you don't. You eat one apple, feel unsatisfied, and reach for processed snacks to fill the void. The food industry has exploited this. They engineer hyperpalatable, calorie-dense, nutrient-poor foods that trigger cravings but never deliver satisfaction. The loop is endless. The body is starving, and the more you eat, the hungrier you become. The third stage of collapse is the bacterial extinction. In the 1970s, a new class of agricultural chemicals entered the market: herbicides. The most widely used is glyphosate, sold under the brand name Roundup. Glyphosate is a broad-spectrum herbicide, meaning it kills almost any plant it touches. Farmers spray it on fields to eliminate weeds before planting crops. Later, biotech companies engineered crops that are resistant to glyphosate, allowing farmers to spray entire fields without killing the crops themselves. It was hailed as a breakthrough in weed control. But glyphosate doesn't just kill weeds, it kills soil biology. Glyphosate works by inhibiting an enzyme called EPSP synthase, which plants and bacteria use to produce essential amino acids. Without this enzyme, the organism dies. The problem is that soil bacteria and fungi also rely on this enzyme. When glyphosate saturates the soil, it acts as an antibiotic, killing the very organisms that make the soil functional. The microbial network collapses. The fungi that transport phosphorus to plant roots die. The bacteria that fix nitrogen die. The ecosystem that took thousands of years to build is sterilized in a single growing season. Studies show that repeated glyphosate application reduces microbial diversity in soil by over 30%. The surviving organisms are often pathogenic, the ones that thrive in disturbed environments. Beneficial microbes, the ones that suppress disease and enhance nutrient uptake, are wiped out. The soil becomes not just depleted, but hostile. Plants grown in glyphosate-treated soil are weaker, more susceptible to disease, and less nutritious. They are surviving, not thriving. Glyphosate doesn't stay in the soil. It leaches into groundwater. It runs off into rivers and streams. It contaminates drinking water. Testing has found glyphosate residues in breakfast cereals, bread, beer, and honey. It is in your body. Studies detect glyphosate in the urine of over 70% of people tested in developed nations. You are consuming an herbicide designed to kill bacteria, and it's not just killing bacteria in the soil. The fourth stage of collapse connects the soil to your gut. Your digestive system is an ecosystem, just like soil. It contains trillions of bacteria, fungi, and other microorganisms that break down food, synthesize vitamins, regulate your immune system, and communicate with your brain. These organisms are not passengers, they are essential. Without them, you cannot digest fiber, absorb certain nutrients, or fight off infections. The gut microbiome is as critical to your health as your heart or lungs, but the same forces destroying soil biology are destroying gut biology. Glyphosate, antibiotics, processed foods, and chronic stress all decimate the microbial diversity in your intestines. Glyphosate, in particular, targets the same enzyme pathway in gut bacteria that it does in soil bacteria. When you consume glyphosate residues on food, they suppress beneficial gut bacteria like Lactobacillus and Bifidobacterium, while allowing pathogenic bacteria like Clostridium to flourish. The balance shifts. Dysbiosis sets in. Your gut becomes inflamed, leaky, and dysfunctional. The connection between soil health and human health is direct. Plants grown in microbially rich soil produce compounds called polyphenols, which feed and support your gut bacteria. Plants grown in sterile, chemically fertilized soil produce fewer polyphenols. When you eat that food, your gut bacteria starve. The diversity collapses. You become more vulnerable to autoimmune diseases, depression, obesity, and chronic inflammation. The weakening of the soil is the weakening of the human body. We are not separate from the ecosystem. We are part of it. This is why your grandfather was stronger. He ate food grown in living soil. That food was dense with minerals and supported by a thriving microbial network. It nourished his gut, which in turn supported his immune system, his energy levels, and his resilience. He didn't need supplements because the food itself was complete. You eat food grown in dead dirt, sprayed with chemicals, harvested before it's ripe, and shipped thousands of miles. By the time it reaches your plate, it's a shadow of what food used to be. You're eating the appearance of nutrition, not the substance. The United Nations has issued warnings. At current rates of soil degradation, the world has approximately 60 harvests left. 60 years before the topsoil is so depleted and eroded that it can no longer support industrial agriculture. This isn't speculation. This is based on measurements of soil loss, organic matter decline, and desertification rates. Every year, we lose over 24 billion tons of fertile soil to erosion and degradation. That soil took hundreds to thousands of years to form. We are destroying it in decades. When the soil is gone, the system collapses. No amount of synthetic fertilizer can compensate for the total loss of topsoil. Crops will fail, yields will plummet, food prices will skyrocket, entire regions will become unable to grow food. The global food supply depends on a resource we are actively destroying. And unlike fossil fuels, which can be replaced with alternative energy, there is no substitute for soil. You can't eat oil. You can't synthesize minerals from air. Soil is the foundation of civilization, and it's disappearing. But the collapse isn't inevitable. Soil can be rebuilt. The answer is regenerative agriculture, a system that works with biology instead of against it. Regenerative practices focus on feeding the soil, not the plant. This means using cover crops, rotating crops, integrating animals, composting, and eliminating synthetic chemicals. It means treating the farm as an ecosystem, not a factory. Farms that adopt these practices see dramatic improvements. Soil organic matter increases, microbial diversity returns, water retention improves, and the food grown in that soil is nutritionally superior. Studies comparing regeneratively grown produce to conventionally grown produce show measurable differences. Regeneratively grown tomatoes contain more lycopene. Regeneratively grown wheat contains more protein and minerals. The plants are healthier because the soil is healthier, and when you eat that food, you become healthier. The loop closes in the right direction. Feed the soil, feed the plant, feed yourself. This requires a fundamental rethinking of agriculture. Industrial farming prioritizes yield and efficiency. Regenerative farming prioritizes resilience and nutrition. It's slower. It requires more knowledge and attention. But it's the only system that builds soil instead of mining it. And it's the only system that can sustain human health over the long term. The weakness you feel isn't a personal failure. It's the result of a food system that traded nutrition for convenience. Your grandfather wasn't stronger because he worked harder. He was stronger because the earth was alive. If we want that strength back, we have to bring the earth back to life. Subscribe if you want to understand the systems that fuel your life, or your